Hello everyone. So today in this lecture we'll be discussing about Rayleigh Jeans law. Well, it will be basically RAY Rayleigh. Apologize for the mistake. So today's lecture will be based on Rayleigh Jeans law, which who proposed the classical theory behind blackbody radiation. Obviously, it was a failure because the quantum theory prevails. So today's goal will be to discuss that how Rayleigh jeans actually approached the problem by classical theory and why it was a failure. So let's get started. Before starting about the core concepts, we'll be knowing about 1D box and 3D box. Well, I have described about 1D box in this in the first portion. 1D box actually involves two perfectly reflecting walls at x is equal to 0 and x equal to L. Now we consider a standing electromagnetic wave in it. Then the conditions for wavelength is equal to k is equal to a pi n by L, where k is equal to 2 pi by lambda, as we know, and length of the box is equal to integral multiple of lambda by 2. Hope you get it. So one thing to realize is that in a 1D box, wavelengths of light will be composed and will be confined in it, such that the wavelengths half into an integer is equals to the length of the box. Okay. Now we will be extending the discussion to 3D box. What about the 3D box? In 3D box, it's something like you have three axes x, y, z, and a cubical box is actually consist of perfectly reflecting walls, right? And this cubical box uh, confines many electromagnetic waves of different wavelengths, and all of these are standing waves. In that case, there will be some waves like this, there will be some waves like this, and there will be some waves like this, right? Hope you get it. In that case, we'll be defining kx, ky, kz. One thing to note that kx, ky, kz actually represents the wave vector. For any wave, we write a sine omega k a sine k vector dot r vector minus omega t, and k vector actually gives the direction of propagation. Similarly, for a wave confined in the box, we'll write kx is equals to pi nx by L. Now nx is also an integer. Similarly, ky is equals to pi ny by L, kz is equals to pi nz by L. Okay, so these three relations are very important. Now mod k vector is given as under root kx square plus ky square plus kz square. So on further simplify, I hope you will get something like pi nx square plus ny square plus nz square upon L square is equal to k square, and we define nx square plus ny square plus nz square is equal to n square. It is something small n square by L is equal to k square, and there will be L square and pi square also, pardon, and k is equal to 2 pi by lambda, so we will write 4 pi square by lambda square. From here we will get n is equal to 12 by lambda. Thus n can be written in form 12 by lambda, and n is a number which is defined as under root nx square plus ny square plus nz square. Okay. Now I will consider another 3D coordinate, and I will name it as a number space. So this is a number space which consists of nx, ny, and nz, right? So in this number space, I consider a vector which is given as n vector. It is at a distance mod n or n from the origin. Now in this n vector, I consider a sphere. Okay, I consider a sphere whose thickness is dn. Now we know that nx, ny, and nz all are positive, so we'll only consider the volume of the only one quadrant of this thin spherical cell. So basically, we'll be considering a volume of something this, as illustrated. It will be like this. and the volume of this thin spherical cell in the first quadrant would be 4 pi n square dn. This is equals to dv. Now, one thing observe that n is equals to 12 by lambda. So dv is equals to sorry dv is equals to 1 by 8. Here it will be a factor of 1 by 8 because we are considered only one quadrant. So it will be 1 by 8 into 4 pi into 4l square by n square, where and dn is given as, it will be lambda square, sorry, 4 pi 4l square by lambda square into minus 2l by lambda square d lambda. Now for now I am considering only the magnitudes, so I will take mod both sides. So dv will give the number of states which will be given as dn, and I can further write it as n lambda d lambda, where n lambda gives the number density, that is how many such states are possible in a interval of lambda and lambda plus d lambda, right? And on further evaluation you will get it 4 l cube by lambda to the power 4 d lambda into pi. Since we consider a box of length l, so l cube can be written simply as volume. So it will be volume times pi into 4 by lambda to the power 4 into d lambda. You will get a number of states possible in a thin spherical quadrant. Now, one thing to notice that if you consider a wave along the x-axis, then the polarization can be either along y-axis or along the z-axis. So each state of wave actually corresponds to direction of propagation. Now each direction of propagation can have two possible states, so it will also be multiplied by a factor of 2. Now, for your information, let me say one thing. In many places, I have also seen the explanation like the harmonic oscillator has two modes of vibration. In this case, that is why the energy is twice. So the harmonic oscillator, there will be a factor of 2 instead of 1. Now I am not sure about which description is correct. I have seen in one YouTube channel, sir, that sir, I have seen from one of the sir from YouTube that who told about the polarization region, and in one of the handout I saw about uh, your harmonic oscillation region. But I would like to say, if anyone watching this video knows the exact reason, you are free to comment below about which region is correct and why. So the number of such possible states is basically equal to 8v pi by lambda to the 4 d lambda, right? Now, what is this corresponding energy? What is the energy confined in this region? Now, energy of one harmonic oscillator is written as E. Small. It is also like some epsilon. Epsilon is written as kBt. This is the energy for a harmonic oscillator. So I can write dE is equals to dN into E, which will come out to be 8v pi kBt by lambda to the power 4 d lambda. So the energy confined in this region will be 8 pi v kBt by lambda to the power 4 d lambda. And if you ask me about energy density is written as energy by per unit volume, and volume is L cube. So the differential energy D, this is written as U. So du will be written as dE by V. Now dividing it by V, both sides, we will get dE by d lambda is equals to 8 pi kBt by lambda to the power 4. And this is a very powerful formula. We must know about this. Gives basically the energy density between two corresponding wavelengths. Means suppose you are considering a wavelength of lambda to lambda plus d lambda, then the energy per unit area or the energy density, basically better to say the energy density confined in these two wavelengths, is given by this formula. So this is a actually a three-star formula. One must remember it. Very very useful. Now one may ask about how can we derive in terms of frequency. Well, for frequency, lambda is given as c by nu. From here we will get d lambda is equals to c by nu square d nu, not considering the negative signs. and lambda is c by nu, so we will get dE by c by nu square d nu is equals to 8 pi kbt by lambda to the power 4. What is lambda to the power 4? C to the power 4 into nu to the power 4, means in the denominator there will be a c to the power 4. Cross multiplying both sides by c by nu square, so whole the left hand side whole terms cancels out, and in the right hand side you will get 8 pi kbt by c cube nu square. And that's what Rayleigh Jeans proposed about how the spectral density actually varies if we consider a classical model. Of course, as mentioned in the first, the Rayleigh Jeans formula was a failure. Yeah, but it worked well for those radiations whose lambda is very high, that is the wavelength is very high, or frequency is very low. So for these two cases, these formula worked well because the observed and the calculated were something like this. The observed was this as a function of lambda, and the calculated, I am marking with red, is something like this. This is Rayleigh Jeans, and this is experimental, where the x-axis actually gives me dE by d lambda, and sorry, y-axis gives d by d lambda and x-axis is lambda. Similarly, for frequency you will get a parabola, and as per the Rayleigh Jeans, but it also doesn't matches with the conditions and the experimental data. Then enters our new scientist whose name is Planck, which will be discussing about the in the next video about what did Planck do and how did he quantize. Actually, Planck did what was that instead of doing blindly about integration, he thought of doing summation and defining discrete energy states. So stay tuned for the next video. Now, one may ask that why you are studying this kind of things because these are not in the 10 plus 2 syllabus. Well, let me explain you. These kind of blackbody radiations, the spectral density is just given a just in NCRT or any of your standardized textbooks, because this makes the Olympiad teachers to get an Olympiad, not only Olympiad also, even JEE advanced teachers seeks interest towards this because this is generally least touched topics by every students. Well, if you carefully observe, this is also similar to the Maxwell-Boltzmann distribution graph, which is of form probably e to the power minus mv square by 2kbt into 1 by t to the power 3 by 2. Well, something it was something like this only. Pardon me if I am written the other factor wrong, but this factor was involved in the first in the problem. So, how the advanced setters and the Olympiad people actually approaches to make this a question? First, they will ask you about the 1D box. Clear? So, this derivation is easy about the 1D box for an electromagnetic wave situated or confined in a 1D box whose other two walls are reflecting. Then they will try to extend it towards the 3D box, and they will explain you to find a number of states within a wavelength of lambda to d lambda to lambda plus d lambda, and then in that case you have to define a number space. They will ask you this. Now this two factor concept they may be giving you in this problem, and even if you miss it, probably they may or may not cut the marks, because this two factor, you can say that it was basically an assumption of polarization or harmonic oscillator. Most probably they will give you about the two factor considering as polarization or harmonic oscillations. Then they will give you the formula of kbt and ask you to find the energy confined in this states. Then you will find the energy, and they will finally ask you to find the dE by d lambda, that is the spectral density per unit wavelength. Then and finally they will ask you to plot a graph, and they will possibly give you a sample graph and ask you in which region the Rayleigh Jeans graph actually fits well. And they may also give you some data like instead of verifying they will ask you to basically they will give you some data like d by d lambda and relation between d by d lambda, and they will ask you to plot a graph between ln d by d lambda and ln lambda, and you have to find the power 4 using this. Possibly they will be giving you various values, and you have to pick up those values where lambda is very high in this case. So these are few possible questions they can ask, and even after finding the relation with lambda, they will finally ask you to find a relation in frequency, and then they will just write that this is actually a failure, and they will enter into the uh, Planck's theory. So in the next video, we'll be discussing about the Planck's theory regarding black body radiation and about many other things. So stay tuned. Have a nice day. Thank you.